Alrighty. So we're going to go over the review sheet. We're not going to spend more than about 5 minutes on this review sheet. So hopefully you already have your review sheet open and ready to go because it's time to rock and roll before we get to the test. Yes, we are taking a test right after this. Yep, you're going to get a periodic table and you're going to get that sheet that says decomposition on one side and synthesis on the other. So let's take a look at questions 1 and 2. In questions 1 and 2, we're only given reactants, and the right side is blank. The product side is blank. So we're going to have to figure out how to combine these reactants to make those products. The way we identify them is knowing what we have. The first problem, we have magnesium and hydroxide, and we have hydrogen and nitrate. So what we have is we have a compound that's positive and negative, and then another compound that's positive and negative. So this is your classic setup for a double replacement reaction. We put the new combination together on the other side. The magnesium has a positive charge, so it has to be paired up with a negative from the second compound, and that compound would be nitrate. So we put magnesium and nitrate together, and since nitrate's a -1, it took 2 nitrates to balance out magnesium's charge. Then we also put together the hydrogen and that hydroxide, and we made water. HOH is water. After we put them together, we then need to balance the reaction. Since there were 2 nitrates as a product, we need to put a 2 over here so that there are 2 nitrates as a reactant. That also hit the hydrogen, but if you notice there were 2 hydroxides and 2 hydrogens, that means there needs to be 2 waters. So again, first we used the charges to make the products, then we did the balancing, and the last thing is going to be the states of matter. We do the states of matter using the solubility rules or just a little bit of logic. So magnesium nitrate is aqueous based off of the solubility rules on the back of your periodic table. And then HOH is water. Water is either going to be a liquid or it's going to be a gas. It would only be gas if this reaction was really, really hot and producing fire or something like that. And this is just mixing 2 chemicals together that are already in water. So, I mean, if you look at this, we're mixing something that's dissolved in water with something that's dissolved in water. So when we make water, it's probably just going to be a liquid. We see the exact same thing going on in 2. Let's go ahead and write down those 3 steps, though. So let's write those 3 steps down. First, we use the charges to make our new compound. Then we need to balance the reaction. That's my abbreviation for reaction up there. And lastly, we need to worry about solubility to figure out our states of matter. If we see that something is soluble, if it's soluble, we write down aqueous. If it's insoluble, then it would form a solid. In number 2, we have 2 compounds. They're going to have a double replacement. We use the charges to put them together, and we figure out the states of matter and balance them. Number 3, we have a combustion reaction. Anytime we have hydrocarbons and oxygen, we make carbon dioxide and water when there's plenty of oxygen. We're going to see a different example in a little bit. Right here it says excess oxygen, so this carbon's going to get ripped off, and each carbon has 2 oxygens attached to it, known as carbon dioxide. After we make the 2 compounds, carbon dioxide and water, we need to balance the reaction. And combustion reactions involve lots of fire. This is going to be burning. There's going to be lots of heat given off when you burn this gasoline or octane. That's what this is, octane here. And when we burn that octane, it's going to give off so much heat that we make gaseous carbon dioxide and gaseous water. We actually saw an example of that in class the other day. It wasn't gasoline, but it was acetylene. Number 4 is another double replacement. I've gone over these a dozen times. You make the new combinations, you balance the reaction, check the states of matter. 5 is a single replacement. The single replacements, we have that single element and a compound, and you need to go to the back of your periodic table and look at the activity series, and it's either going to be the activity series for metals or non-metals. How do you know which activity series to use is a pretty common question, and that comes down to what element is by itself. Since bromine is by itself and bromine is a non-metal, then you should use the non-metal list. bromine and iodine are both nonmetals, and bromine is higher on the list. So as you can see, I'm comparing these two elements. Since bromine's higher on the list, it's going to steal iodine's place with sodium. So we have sodium together with bromine afterwards. Just like before, when we put them together, we're going to use charges, balance, and then states of matter. I thought I had paused it, but evidently I didn't pause it. That's why there's that awkward silence there. Sorry, guys. So I put the sodium and the bromine together using their charges. I then balanced the whole reaction, and then I used the solubility rules to figure out the states. Number 6. For number 6, we're dealing with a synthesis reaction. We have zinc and oxygen coming together to make one product. You use your activity, the piece of paper you're going to get, the synthesis piece of paper, to figure out which one it matches up with. So number 7 is also a synthesis one. You would look and see which one it looks closest to. It looks like the one where you have metal oxides and water coming together. 3 is another double replacement. Number 9 is a decomposition. We're breaking the compound apart with electricity. Number 10 is a single replacement. Is chlorine a metal or a non-metal? Well, since chlorine is a non-metal in number 10, it can take the place of the bromine. Number 11 is a compound being broken apart by heat. So that's a decomposition reaction. And number 12, we have copper. Is copper by itself? Is copper higher than zinc? Oh, that's not right. Is copper higher than silver on the metals activity series? Why, yes, it is. So we have a reaction where copper has stolen the nitrate away, and now the silver is by itself. Number 13 is incomplete combustion. The butane is being broken apart by the oxygen. This time, though, let's kind of focus in here. This oxygen is limited. It is limited. And when you have a limited supply of oxygen, you can't have one carbon and two oxygens. You have 1 to 1. So we end up making carbon monoxide right here, CO. And carbon monoxide is a poison, so we don't want to breathe that in. But with a limited supply of oxygen, the products change just slightly. We make carbon monoxide and water. After we write down the two products, we still have to balance the reaction and then do the states of matter. 14 and 15, 2 more double replacements. We switch who the metals are paired with. We use the charges when we put them together. Then we balance the reaction. After we balance the reaction, we use the solubility rules. Good job. Good job. 15, another same double replacement. Lead and chlorine are insoluble, so they're making a solid over there. We have another decomposition using heat. We have another single replacement. Fluorine is a non-metal, and it's the highest on the list. So that means fluorine's going to take the place of that chlorine. And then we have potassium and fluorine together, and chlorine is all by itself. And one more decomposition. It's an acid decomposing. There we go. Oops, too far, sorry. 19, we have a synthesis reaction because we have two things coming together. This one can look a little bit odd, though. A lot of people see 1, 2, 3, 4, and they think they're looking at a double replacement. But usually it goes A, B, C, D, where they're all four of them are different elements. This one has oxygen in both compounds, and so you can't just switch them around like you do a double replacement. They can all combine together, though, as they are in this one, so it's a synthesis reaction. And then for our last one, I want you to think about why iodine is not reacting with that compound. So iodine is trying to replace the chlorine because they're both nonmetals. We look at the activity series, and here's what we're going to see. We're going to see that iodine is lower on the nonmetals list than chlorine. So if iodine is lower on the nonmetal list than chlorine, that means it can't replace the chlorine. chlorine is already attached to the magnesium, and it is stronger and more reactive than iodine, so we're not going to see a reaction between iodine and the magnesium. The same thing can happen on the metals list. If the metal that's by itself is lower on the metals list than the one that's paired up, we would have no reaction. So if this, instead of being iodine, if this had been gold, gold is obviously on the metals list. We would compare gold against magnesium. Gold is at the bottom of the list. It's one of the least reactive metals. So nothing would happen. The gold couldn't take the magnesium's place with the chlorine. Number 21. And number 21, we did this the first couple of days we were working on these, the dissociation reactions. All this means is that when the solid is in water, if that solid is soluble, let's write soluble down, if the solid is soluble in water, then it breaks apart the solid. The solid breaks into its ions. And we did this a bunch on the first day and in the notes. Number 22, write the letter equation for a single displacement. This is where we show that the one element is taking place of the other. So if C is a metal, it could take the place of A. If C is a non-metal, it could take the place of B. What combines with oxygen in a combustion reaction? Some sort of carbon and hydrogen combination where X and Y are numbers. How do we determine the states of matter for double displacement reactions? We look at the solubility rules, which are found where? On the back of the periodic table. Yeah, it's hard to hear you there in the back, but you're right. The solubility rules are found on the back of the periodic table. Feel free to look back there on a regular basis during the test. That is, if you want to get those questions right. 25. What two products do you get when you react an acid and a base? That's a pretty classic, easy issue. So here's an acid, HCl. Here's a base, NaOH. They react, and the Na and the Cl come together, and then the H and the OH come together. So we make a water molecule, and we make some sort of ionic compound or salt. Questions 1 and 2 had this going on. The ionic compound is not always NaCl, but it is a metal and a non-metal put together, like we had in 1 and 2. Alrighty, and that ends our review. I strongly suggest you take your time, but keep in mind that you do need to finish before the period is over. Use the periodic table. We do know that the periodic table, let me grab a periodic table real quick. On the periodic table, some elements have a set charge, like the first two groups are +1 and +2, right? And we skip all the way to the other side. Skip pretty far actually, and let's go over there. The one with boron is +3, and we kind of skip a group, and then we go -3 for the nitrogen family, -2 for the oxygen family. And what about those halogens? -1. Noble gases don't play this game. In the middle, we use Roman numerals. Roman numerals are the ones that give us the charge. So if you see a Roman numeral of 2 on iron, see iron 2, that means Fe is a +2 charge, right? So they use those Roman numerals in the middle there to kind of help you out again. And of course, you're supposed to know all of those polyatomic ions. No, I'm not giving them to you. You need to know them. Alright, let's clear everything off. You shouldn't need a calculator for this test. All you're going to need is what you have. Alright, good luck, guys.